All right, welcome to IA 215. Today we are going to complete our system design discussion. Um, we're going to complete it by also talking about the last few steps on a completed automated system, which is systems integration and testing and commissioning, because we always want to begin with the end in mind. As we design our modules, as we design how these different components that we selected previously, we had other classes on how to select the right components, but now we need to put all these components together and have them talk to each other. And so we're going to be defining modules within our system that break up the system. Because if we look at the system as one big whole mass of things, it's really hard to effectively test it. And if you've done any serious troubleshooting, you know, if you look at your entire system out there as one big mass integrated pile of electrical stuff, it's hard to figure out how to test it if you're troubleshooting a problem. What you want to do is break it up, maybe not physically, but in your mind, break it up into separate areas of different functions. In the case of a simple motors and controls, you might break it up into, well, there's the power, right? Power module, which is three-phase coming in, converting to some control voltage, which I could then use. That's one module. And then I might have the basically the buttons and switches portion of the system, which basically latches on or unlatches a coil, which will turn on the motor eventually. And then the third module might be your contactor with your overloads to make sure that when you do turn on that coil, you get energy down through and out the overloads down to the motor, and the last module might be the motor. So you do that, you don't physically break them up when you do troubleshooting for the most part, though you do sometimes disconnect the motor and test things separately. But you can break them up if you want to physically and test them separately. At least you want to break them up mentally so you can test each portion of that circuit separately as you step down and look for a problem in that circuit. So systems, larger, more complex systems, are very similar to that simplistic example that I gave you. You're going to be talking about how to break up that system into its components in a logical way. So let's begin by switching to my Sharpie cam. All right, so we're going to talk about this here, and we're going to say, let's adjust this. Begin with the end in mind. Always begin with the end in mind. For systems, right? And everything that you're going to be testing. So for systems, the end is your testing and commissioning and handoff to your customer. But the testing is really where the rubber meets the road. You'll know whether it all works when you test it. So the end in mind that we're going to focus on is the testing. Yes, I know my handwriting is terrible, but we're going to talk today about modular design, testing, and commissioning. So modular design, testing, and commissioning. That's the name of this lesson, modular design, testing, commissioning. So let's talk about the overall process for modular design, testing, and commissioning. And we're going to dive into each one of these processes a little bit. And we're going to probably try to throw out some examples of this stuff. So let's begin with the end in mind. So the end we're going to talk about is going to be this end. So I'm going to cover up the rest of this stuff, and we'll have just this end here. And this end is the testing. So you've got modular tests, number one. That means you test each component in the system prior to integrating it. The second step is integration test. And then the third step, and sometimes people break this up into multiple steps, is the overall system test, which includes stress testing. Stress testing means you run it to maximum speed in every possible way. So you got system and stress testing overall. So there's 3 major phases to testing. But to get there, we must define those tests. And we have a commissioning process that occurs somewhere along the way. Sometimes it's done after you do all these tests. All these tests are done offline somewhere in your shop, in your testing area, and then you install it and then you commission it. And sometimes the commissioning happens, you do your modular testing, then you install it, then you run your commissioning, and then you do integration testing and stress testing. So the commissioning is sometimes integrated with the test. It depends on how big the system is and what facilities you have for doing your testing. All right, but all of those, it defines on the tests have to be defined. And before you define the tests, you have to then first, before all that stuff, define the modules, and as part of the modules, the interfaces, and define the flow charts, which defines the function of each module. So each module you need a flow chart for. So I've used the word commissioning a lot here, and I was thinking that now might be a good time to pause and talk about what commissioning is. Jonathan did a great job of describing commissioning from a user standpoint, and then what he described is basically what a typical user will see when a full system gets commissioned. But I want to take this time and jump in and talk about commissioning, because we all kind of know what testing is. We understand intimately what that is. You think the system should do something, so you trigger that something, and if it does it, yay, test is great. All right, if the system doesn't do it, then boo, test fail, you're done. But the commissioning is something where we need to define a little bit more. So I'm going to pause the video a little bit here, and then we're going to start talking about what commissioning really is. Plus, I provided you a few videos to talk about commissioning from a single PLC system onto very large integrated systems. So let's go ahead and pause the video. Okay, so let's talk about commissioning. We paused a little bit at the end of that, kind of an overview of the module breakdown and testing process, but now we're going to talk about commissioning. The first step is to spell it properly. Commissioning. Commissioning is an area in our business where contractors make a boatload of money. Commissioning is also an area in our business where it's easy to get it wrong. Easy to get it wrong, and easy for a customer to end up with a integrated system that they're very disappointed with after a few months or years, and very angry at the consultant for providing them. So commissioning has to be done right. Some parts of commissioning are pretty easy. So the first step in commissioning, the idea is you're doing commissioning after a system has been installed or during the installation process. The commissioning often starts well before the actual installation as part of an integrated commissioning process. But typically, the integration first starts with, we'll call them ring outs. Or wiring tests. So a ring out and a wiring test is essentially when you've got, say, your electrical drawings all laid out in front of you, you one by one verify that the wire on the drawing is a wire that is running in the plant to the correct location in that plant. Sometimes it involves just a visual check, and more often it will be an electrical check. And this is where sometimes we use specialized electrical equipment. to verify we've got the right wire all set up. Not all ring outs test wires individually. Sometimes we might test wire cables, and then we may only check a couple conductors per wire cable if we're running a large number of conductors to different plants. However, the ring out thing is becoming less and less of an issue in our world of commissioning because of the greater number of Wi-Fi or Ethernet integrated sensors and different instruments and different kind of controllers. We have a whole lot of equipment now that'll just hang off the Ethernet somewhere or be wireless. So the old day of spending days doing ring outs and wiring tests is starting to fade into the past. The second thing, which is still extremely important, is grounding. Grounding, and the video guy calls it earthing. Earthing. You got to make sure that all major systems, all panels that you've installed, all the robot, the HMIs, everything that you've installed is properly grounded. And I can't tell you how many times I've seen that screwed up. And with grounding, you're going to verify not only you see a green wire and then it's hooked up to a ground wire that goes to your building ground, but you're also going to test it with a multimeter and make sure that you don't have any floating grounds and everything is grounded out to the same level everywhere if they have any physical interactions. Once again, in the world of Ethernet or Wi-Fi connected devices, grounding is a little bit less of an issue, but we still want to do that very, very carefully. The third step in integrated system is basically we're going to call it cable tests, where for this would be for any kind of instrumentation. So you want to make sure that all of your instruments can communicate over the wires that they're supposed to be communicating with. This is the layer of, Ethernet. You have some Ethernet tests that will be part of this cable testing if it's an Ethernet-based system. You have Modbus. You've got RS-232, RS-45. You want to make sure that all of your communication cables and instrumentation connections are in place. The next one is power. You want to make sure that you got the right power available in the right cabinets. And nowadays we can easily do a graphing voltmeter, and we can take a look at the waveform of that power as well. We can verify we've got good, clean power that doesn't have a lot of spikes. So the power supply is the next check. That's the next check. Once we've powered up all of our devices, so after we check power, we do the power up. Once we check all of our devices, this is where we can do our operational tests. Actually, this is the first level operate test, where we're really checking to make sure that every device in the system can power up and doesn't have any faults, doesn't have any problems powering up, doesn't have the magic smoke coming out of it, making it no longer operate. So we're basically just powering up all the PLCs and making sure that the PLCs and the instruments all power up with no errors. Their little green lights come on where you need green lights, the little yellow lights where you need yellow, and I better not see any red lights. So those are the first 5 steps of commissioning. And generally speaking, you might follow these same steps after you've made a fix to any existing system. You might check your wires, you might check to make sure you have good ground, make sure that your cables are in place, do your power up, check your power, check all of your PLCs, check all of your other instruments, HMIs, robots, whatever you put in there, and make sure they power up properly. Because the next step is step 6. Step 6 is the first step from a system standpoint. We're going to call it safety. I spelled it wrong. I'll have to fix this in post. Anyway, safety systems. Check. So the safety system check, we're going to go through all of the safety systems that are hardwired. In other words, they're not software-based in the PLC. They're all hardware-based. And we're going to verify that each one of those safety systems operates as appropriate. This is the first phase of integration testing. It's the safety system check. And this is for not necessarily the logic-based safety stuff in place. It's for all the hardwired, the limit switches, the e-stops, all those main components that are designed to keep you safe in normal operation. The next step is 7 is I/O. We're going to test the I/O. That means all of your inputs and your outputs for each major system. Now, you probably don't need to test this for a robotic system per se, but it doesn't hurt to do that. For instance, in our robot systems, we know we wired up that I/O, but we can also go before we run that robot program and turn on the outputs and make sure the thing it's wired up to shows that it's turned on somewhere. All right, so you want to test your I/O, and you want to test your inputs. So you might have a sensor turn on. I want to see that that sensor triggers an input to the PLC or to the robot. So we want to test our I/O. And then we're going to test the modules. Now, some integration, some commissioning, we don't test the modules as part of the commissioning. For some, we do. For instance, if my modules are already pre-tested in the shop, and once I've installed everything, it's really hard to test the individual modules, I might skip this step. So the next step would be test the integration. And the last step would be test the system. So you may not perform all of these tests in every single kind of system, depending on who's doing the commissioning. You may only do integration and system testing, but you have to have those. And you may find some things in integration and system testing. And this is 8, A, B, and C. You might find some things in integration and system testing that require that you change a program. So you might have to go back and retest something within a given module. In other words, you might find in the real world, once you've installed that robot in that work cell, the sensor you thought would do A doesn't do A. It really doesn't. So you need to find a workaround that allows you to put in sensor B. And so you have to rewrite your robot program to use sensor B. in the real world. So you might end up retesting something at the module level in that robot. And then the last step, and probably the single most important step, is the handoff and training. And the one thing that almost all integration experts and contractors fall short on is maintenance planning. If you are not planning to maintain and continually improve your integrated system, your system will soon find itself by the wayside within a couple of years in most plants. Just like the one we saw way back when at Pella, they had a lovely robotic system that was pulling components out of boxes. And then as boxes changed over time, they had nobody to go in there and improve the system. Eventually, it just sat there as a showpiece, only fired up once in a while. So that is my little side review of commissioning. Any questions about commissioning? Generally, commissioning even a very large system should never take more than a couple of months. Of course, if you're talking about a nuke plant, it might take a year or more. But for PLC and robotic systems, the scale that we're talking about, it might only be a few days. And for a very small system, maybe only a few hours. So that is commissioning. I'm going to pause the video and ask questions. All right, so now we talked about commissioning because we're talking about the end in mind. Commissioning is often integrated with these tests. And a lot of times when you're defining your modules, you're also thinking about commissioning. So we've talked about modules. You guys have heard the word module, module. What is a module? What is a module? Well, I have a slide for that, or a sheet of paper where I scribbled on with some Sharpie. What is a module? Well, a module, it could be a PLC, it could be a robot, it could be a vision system, it could be an HMI, it could be any self-contained system, any self-contained system. And yes, this particular bit of scribbling is indeed chicken scratch. Or if we're talking about modules, it could be software inside of a PC. And God, that's a terrible PC, isn't it? This is a terrible PC, but I'm trying to give you the idea that stuffed inside that computer are software modules. There are separately programmed bits of computer software that somebody wrote that you install inside a computer that all talk to each other, or that module may talk to a different computer at a different location, or even a PLC. So these are modules as well. Now, I'm describing these modules for the sake of completeness here. These software modules probably aren't ones we're going to run into in our experience with automated work cells, but they do exist. The more complex the system is, the more likely you might run into multiple software modules in a PC like this, or in a mainframe computer, or in even a PLC. If you have a very complex PLC application, sometimes you have different ladder logic or other software modules that run independently in that PLC. So those all are things that could occur as modules. For example, let's talk about the lab that we have out there right now. You've got in the lab several obvious modules. An example of one module that's easy to find is the robot module. And for each module, the first step is define the module. And it's pretty easy for the robot. You just say, it's a robot. It's this model. It's supposed to do this. and you do a brief description. For that robot, you define the physical interfaces. So what's a physical interface? It's when the robot pushes a button by the robot actually pushing the button with the gripper. There might be a number of physical interfaces. The robot's the only example of a module that will get a physical interface. In every other module, you're going to have system interfaces. In the case of a robot, we've got I/O. And so our I/O list is the system interfaces, the inputs and outputs associated with what's going to communicate to that robot. If we wire up push buttons to the robot I/O, then those push buttons become part of the interfaces, because the real world, is now communicating to the robot by pressing a button. The second step is you define the function of that module. And when we define function, the most acceptable way of defining the function is to put together a simple flowchart describing the steps that robot's going to go through, where it's going to pause, where it's going to make decisions, and how it's going to loop over and over and over. And you also want to describe the interface function. So an interface function, you could write it as a flowchart, or you often can just describe it as a sentence. For instance, the robot will pause when this I/O is high, when it reaches this step, and then continue when this I/O goes low. So that in that case, you're just describing how that interface function will work. And generally speaking, you will write one interface per system interface. And in terms of I/O, it means you're going to have one description per point in that I/O list. Now, not all system interfaces are I/O. Some system interfaces will be through Ethernet or other communications means like Modbus. So you have to remember that in our very simple examples in our simple lab, we don't have these complex system interfaces. So it may seem a bit silly to describe each one of these interface steps individually. At this point, it is kind of a little bit simplistic, but you have to realize that in some cases you might end up with very complex interfaces that need to be laid out one by one to describe how they're going to work. All right. So then the next steps are this. For each module, you're going to define a module test. And what is a module test? It's simply a list of test steps. So you might have, can the robot pick up the part? That is one test. If the part is picked up, can the robot place it in front of the vision system? Boom, that's another test. Can the robot put the part onto the pallet correctly? That's another test. So each step of the robot then becomes a simple test. And you might actually combine them in a list. You know, robot moves from A to B to C successfully without hitting anything in between. And each test step has a criteria. So robot doesn't hit anything. Robot has a cycle time of 3 seconds to move the part from A to B. So each success criteria is listed per step. Now, in our labs, we're not too heavy on performance criteria. I don't push hard on you guys to maximize the speed of the robot, but for any production system, they do have performance criteria. They want that robot, they want that machine to run at a certain rate. So our success criteria for those real world systems might be performance related. Now, when we're talking about module tests, we are talking about testing that device before we've integrated it with anything else. I know you guys are like, whoa, Rob, I already wired them all together. Why would I want to test things individually if I've wired them all up? Well, the trick is, in most projects, you don't have the luxury of wiring all components, all the modules together ahead of time. So an important step is to create a simulation so that before I wire up the different modules, before I wire up that robot to a PLC, I have to have a way of testing to see if my robot program will work successfully. So I might not wire it to the PLC right away. I might get a push button and use my push button as a simulated communication from the robot, from the PLC to the robot. So I need to come up with a simulation method. So even though, this is a key thing for you guys, even though in some cases, and I know one of you at least, has already wired up these systems completely, I want you to describe how you would test that module, how you would do a simulation method for each of these test steps that is integrated with some other system. So how are you going to simulate it? And it could be replace IO, robot IO 0 that hooks to PLC IO I03 with a push button, so a push button test. So you would just describe how you would simulate that. And for each module test, you're going to get something called a punch list. And after you finish testing it, you're going to have to decide how you're going to retest. Do you retest the entire thing? Do you make a fix and just retest one component? And it depends on what you're fixing. If you're fixing enough stuff, yeah, you probably want to retest everything. If you're only fixing one little thing and you're sure it's isolated, then you may only have to retest one single little thing. So you have to decide that as you run through your punch list, how you're going to do your retests. And somebody has sent me a chat about punch lists. Oh, so I have from Jonathan here a little note. Punch list comes from when people used to punch a hole next to the item on their to-do list once it was done. Like then, today, the punch list means that the project is substantially complete. Excellent. I love that. So that's from Wikipedia, probably. Excellent. So after we do our module tests, now we have to do our integration tests. So the first step is define them. Define the integration test. We may not need to run through the whole robot program or the whole PLC program. The integration tests means that we just make sure in that integration point, like when I'm sending a signal to the vision system, right, that the vision system snaps a picture and gives me a signal back. So I may restart my robot program only for one particular test. And just like your module tests, for each integration test, you're going to have success criteria for all systems that you're integrated with. And you may have something called ramping connectivity. In other words, I may not connect everything all together at the same time and test everything all together. I may add one component at a time, one module at a time, and test that integration first before I add another module. And this is a really good method of testing, especially if you have a whole bunch of modules that all hook together on, say, Wi-Fi or Ethernet, in which case they may interfere with each other. And if you try to test them all at the same time, all hooked up at once, you may not figure out which module you're adding is causing the problem. So by breaking the testing down into one module at a time, one integration point at a time, and ramping up, adding them one at a time after that, you reduced your test complexity and confusion. And of course, with integration testing, you get a punch list. You decide what modules you may need to retest and what integration points you may need to retest. Obviously, if you had to edit a module, edit your PLC program or your robot program, then you're going to have to go retest that program too. The last series of tests is, I call, the systems and stress tests. This is when you do the robot going entirely through the process, verifying that it integrates properly with every component, PLC, HMI, vision system, and so forth. and you are going to be looking at maximum rates and maybe minimum rates. You also want to look at maximum data. We don't really talk a whole lot about data in our current systems because we don't have any way of utilizing it in terms of AI or artificial intelligence or reporting. However, a lot of systems do collect data. And when we collect data, we want to make sure that we don't overrun our data availability. We don't run out of space in our hard drives. And we also want to do something called maximum envelope testing. That really means you crank it up to the maximum specified speed or the minimum speed or the biggest part or the smallest part, and you make sure that every possibility on the end of its use cycle, every worst and best case is handled. And once again, when you do your tests, you're going to have your punch lists and you'll come up with your retest list. And that is it. That's my overall description of modules and the module testing.